Good morning and once again welcome to my YouTube channel, Pearson and Excel International Maths by Mr. Kamoto. And in this video, I want us to look at Pure Mathematics 2 and chapter number 4. We are still doing binomial expansion, but today I want us to learn something to do with factorial notation. Earlier on, we have learned how to use Pascal's triangle to expand functions or for binomial expansion. And I want us now to introduce ourselves to something simpler because you realize that it takes a lot of time developing a Pascal's triangle, and especially when you are expanding a function to greater indices. So in the calculator, there is what we call the factorial button or factorial notation. The factorial button or factorial notation means if we have 5 factorial, this simply means it is 5 times 4 times 3 times 2 times 1. You start from the term itself going down until you get to 1. 5 times 4 is 20 times 3 is 60 times 2 is 120 times 1. This is 120. And it becomes a very easy way of getting the coefficients. It becomes a very easy way of getting the coefficients of the expanded binomials. How is this? We are told that you can use factorial notation and your calculator to find entries in Pascal's triangle quickly. The number of ways of choosing items from a group of n items we can talk about. The button is NCR. And I want to explain what is here. So in this case, we are talking of, or you can also write it in terms of NR, which simply means n factorial all over r factorial multiplied by n minus r factorial. I will explain this. This one should not scare anybody. When we are talking about NCR, it simply means n factorial over r factorial times n minus r factorial. And the r entry in the nth row of the Pascal's triangle, and this is what I want to write down now. The r entry in the nth row in the Pascal's triangle is given by n minus 1 c r minus 1, which can also be n minus 1 r minus 1. And I want to give you an example. It's simply to get, if I want to have, for example, 5 c 0, this is, you take the calculator, you have 5, you look for the factorial NCR button. Mine is here but inverse. Mine is here but through inverse. Mine is this one. Mine is this one but through inverse. So shift division sign 0, you find that is 1. It's 1. And before I do that, I would have brought the Pascal's triangle, the one we know, so that we learn from it. When we have a plus b raised to power 0, we said we are going to have just 1, because anything raised to power 0 is 1. A plus b raised to power 2 is 1, 1. Power 2, power 1 rather, power 1. We have a raised to power a and b. What about power 2? A plus b power 2, we have 1, 2, 1. Coefficients now. A plus b power 3, we have 1, 3, 3, 1. A plus b power 4, we have 1, 4, 6, 4, 1. A plus b and power 5, we have 1, 5, 10, 10, 5, 1. And we want to understand that these are the coefficients when we are raising a binomial to power 5. What we are simply saying is that we do not have to draw the Pascal's triangle to land on these coefficients. We can simply use our calculator, and that is where we started to talk about. If we get the calculator and the power is 5, we say 5 shift NC0, we get 1. This is 5C0, we get 1. Again, 5 shift NCR1, we get 5. The coefficient is 5. This is 5C1. The coefficient is 5. Let's go to the second one. 5 shift NCR2, the coefficient is 10. This is 5C2. The coefficient is 10. Let's go to the next one. 5 shift 3. The coefficient is another 10. So 5C3. Let's go to the last one, to the second last. 5 shift 4. The coefficient is 5. This is 5C4. And the last one is 5 NC5. The coefficient is 1. This is 5C5. Coefficient is 1. So there is something I want to explain here. That when you use 0, 1, 2, 3, 4, 5, you get 6 terms. In every binomial, when you expand to power 1, when you expand to power 0, you get 1 term. When you expand to power 1, you get 2 terms. When you expand to power 2, you get 3 terms. When you expand to power 5, you get 6 terms. That's the first. Every other binomial expansion Pascal's triangle is starting with 1. And this one is simply 1 is generally n. C0 will always be equals to 1. And then NC1, NC, depending on what the value of n is, our n was 5. We are raising our binomial to power 5. What does this mean? This means you can easily get all the coefficients without drawing the Pascal's triangle, so long as you know what you are doing. Always start with 0. And this is a very interesting piece of information, because we know all what you need to know is that the rth term, the r entry in the nth row in Pascal's triangle is given by n minus 1, c r minus 1. We are getting there. We are coming to see what that is all about. And that is why I want us to go through example 3, example 3 on page 865, and let us have 5 factorial, which we said is 5 times 4 times 3 times 2 times 1, which is 120. We had that introduction there. What about, this is part A, part B, 5C2. What about 5C2? This 5C2 is simply what we need to know is, if you use this 5CR is going to be, if you use 5CR to be n factorial, which is 5 factorial all over r factorial, which is 2 factorial, multiplied by 5 minus 2, which is 3 factorial. This is 5c2 5 factorial over r factorial multiplied by 5 minus 2, which is 3 factorial, and you get this to have, this is 120 over 2 multiplied by 3 times 2 times 1, which is 6, which is 120 over 12, which is 10. But you may avoid all this if you use the calculator. Let me show you how. 5 shift NCR 2 is equals to 10. You can see it. 5 shift NCR 2 is 10. You can see it there. So you can avoid all that. But it is part C that we must talk about. The sixth entry in the 10th row of Pascal's triangle. 10th row talks about what power? This is row 1, power 0, row 2, power 1, row 3, power 2, row 4, power 3, row 5, power 4, row 6, power 5. So row 10, power 9. So row 10 is of power 9. Okay, let us talk about the sixth entry or the sixth term. If we use row 6 power 5, this is the first entry. The first entry is C0. The second entry is C1. The third entry is C2. The fourth entry is C3. The fifth entry C4. And the sixth entry C5. So the sixth entry is C5. So we are going to talk about 9C5. In our calculator, this is very easy. 9 shift 5. And what is the answer? Is actually 126. The coefficient for that arrangement is actually 126. Again, this conforms with what I said. The rth entry the rth entry in the 9th row in Pascal's triangle is given by n minus 1 c r minus 1. So the 6th entry in the 10th row is 10 minus 1, which is 9, c 6 minus 1, which is 5, which we have realized here. Exactly 126. This one should not scare you as early as now. I will be explaining a lot of it further, but basically just know you can use your calculator to get the coefficients of binomial expansion. All right?